In the last few videos, we looked at the tan function, and we looked at what the effects of A were and what the effects of Q were on the appearance of the graph. And in this lesson, we're just going to go over a couple of examples to make sure that we have understood that completely. And so with our first example, let's start out by looking at what we would get if we were to graph f of theta is equal to negative 2 tan theta plus 3. So now we're going to be graphing this function, and in purple we have our tan theta function, and it's always good to look at your tan theta function as the baseline and see how your different points at these key angles are going to vary from baseline. I find that that's always the easiest way to sketch out my new tan functions. And what I'm actually going to do here is I'm going to just extend these axes because we're going to need to go higher than 3 and lower than negative 3 here. So I'm just going to quickly extend these axes. Okay, and we're also going to extend our asymptotes. Okay, so we've extended our axes and we have extended our asymptotes. And now in this example, what we're going to do is we're going to focus first on this one period of the tan graph in between 90 and 270. And that's because we know that whatever shape that we get in this period is just going to be repeated over here and here. So if we're focusing on this middle section, what I like to do is I like to look at these 3 angles, and I like to just calculate what we would get for those 3 angles in our new function. So let's start out with 135 degrees. We know that at 135 degrees, tan of 135 degrees is negative 1. We can see that here. So if tan of 135 is negative 1, well, first let's just write down 135 degrees. So we know that tan of 135 is negative 1. That means that this function is going to become negative 2 times negative 1 plus 3. And all I've done is substitute tan 135 in over here, and we know that's negative 1. So our value at 135 degrees in our new function is going to become, well, negative 2 times negative 1 is equal to 2 plus 3 is going to be equal to 5. So that is the point that we're going to get at 135 degrees. Now what about 180? At 180 degrees, we know that tan of 180 is 0. And so our function is going to become negative 2 times 0 plus 3. And that is going to be 3. Now let's do 225. Tan of 225 degrees is 1. And so negative 2 times 1 plus 3 is going to give us 1. So we know that for our new function over here at 135 degrees, we're going to have our value of 5. So that's going to be over here. At 180 degrees, we're going to have a value of 3. So we're going to have a point over here at 180. And at 225 over here, we're going to have a value of 1. So we're going to have our point over here. And now that we've got these 3 points, we can easily find out what we would have gotten here because we know that whenever our value would have been negative 1, it's now going to be 5. Whenever our value would have been 0, it's going to be 3. Whenever our value would have been 1, it is still going to be 1. So over here, we would have had a value of negative 1. Now we're going to have a value of 5. And over here, where we would have had a value of 0, we're now going to have a value of 3. So again, these are going to be the same, so it's quite easy to visualize. Over here, where we would have had a value of 1, we're still going to have our value of 1. And here, where we had a value of 0, we're going to have our value of 5. And if we draw out our function, oh, and I just realized I made a mistake here. When we are at 0 degrees, we should have a value of 3, not of 5. So we're meant to have our value here at 3, not at 5. Remember, when we have our tan theta value at 0, we get 3. So that was my mistake there. So it should be a point at 3 here. And so now for connecting that side, it's going to look like that. If this scale was a lot bigger, we would see that we would be going towards the asymptote over here. As we go more and more higher above 5, we're going to be approaching the asymptote on this side. It's just because it's been shifted up and I didn't have a lot of space in my axis that we can't see that. Just like this way, we're going to go down and approach this asymptote. and we're going to go upwards here and approach this 270 asymptote as we go higher and higher here. So what we can see is that we have firstly shifted our curve upwards by 3 units. We have increased our amplitude by 2, and we are negative. So we can see that now, as opposed to going up to the right in our purple curve, now we're going down to the right. So we have a negative A, and that's why we've changed the shape of this curve. So because our A was negative, we're going down to the right instead of up to the right. One thing that we can notice is that the space between these 3 points is 2 units. Over here we have 5, over here we have 3, and over here we have 1. There's 2 units in between each of these, so between 3 and 5 we have 2 units, and between 1 and 3 we have 2 units. So our A value is going to tell us how many units there are in between these 3 points. We know that with our regular tan theta graph, where we can envision an A value of 1, we have 1 unit in between these 3 points. We go from -1 to 0, that's 1 unit, and from 0 to 1, that's another 1 unit. So we can tell the amount of units in between these 3 dots by looking at this A value. The sign of that value is going to tell us whether we're going to be going up towards the right or down towards the right. And this value, this Q value, is going to tell us how many units we've shifted upwards or downwards. And while this is a foolproof method that's going to work every time, a way that we can make this even faster is to just start out by looking at what we would get when we have our tan theta value of 0. So whenever we would have our tan theta value of 0, we know that the point that we're going to be at that point where tan theta is 0 is going to be our Q value. So we know that tan theta was 0 over here, and over here, and at all of these points our new Q value is going to be 3. And once we have that point, then we don't even need to calculate these other 2 points, because just knowing that there is a distance of 2 units in between those points and knowing the sign is going to tell us exactly how our graph is shaped. So let's say we didn't work out this part where we knew that whenever it was -1, it's going to become 5, and whenever it was 1, it's going to become 1. Let's say we only calculated this, which we can look at just by looking at our Q value. So we knew that wherever our regular tan graph is 0, it's now going to be 3. So let's say we had that 3 point. Now I know because my A is negative that it's going to be shaped in a going downwards to the right direction. And because our A is 2, I know that there's going to be a distance of 2 units in between each point. So I know that my next point is going to be at 5, and my other point is going to be at 1 because I can add 2 and subtract 2. So that might sound a little bit complicated now, but it actually makes it a lot faster and easier to draw out your tan graph when you think of it like that. And I'm going to illustrate that in the next example. So here in purple, we have our regular tan theta graph. And now I'm going to try and sketch out the function f of theta is equal to 2 tan theta minus 2. And so I'm going to use what I was just talking about to try and graph this without having to do a lot of calculations of each of these 3 points. So what I'm going to do is I'm going to start out by first figuring out what I'm going to get wherever my regular tan function equaled 0. And that's very easy because that's just going to be our Q value. When tan theta is 0, that makes this entire term 0. And we're going to be left with our Q value of -2. So that means that we're going to get -2 wherever we would normally get 0. And so we're going to have -2 over here, and we're going to have -2 over here, and we're going to have -2 over here. And what I was trying to explain at the end of the last example is that just by knowing this point, which we can easily determine just by looking at Q, and knowing firstly the sign, we know that we have a +2 over here. So our tan graph is going to be in this same shape. It's going to go up to the right. If we had -2, we would know it would go down to the right. So it would look like an X over here. But now because we have a positive, we know that our shape is going to be in this direction. And now just knowing that and knowing that we have an a value of 2 here, which means that we have a space of 2 units in between each of our 3 points. And so what that means is that we don't need to plug in -1 or 1 for tan here and calculate it in this equation. What we can just do is know that for this point we're going to go down 2 units from here. So we're going to go down 1, 2, and we're going to be at -4. So that is going to be right here. That's down 2 units. And we know from here we're going to go up 2 units for this point. So we're going to be at 1, 2, at 0. So that's going to be this point here. Now we can put in those other points over here because we know that it's going to be just exactly the same as these points. And now if we draw out our graph, we know that our graph is going to look something like that. So this was faster than actually doing what we did in the last example where we looked at those 3 angles of 135, 180, and 225 and calculated what this entire function would be at those 3 angles and then extrapolated that to these portions over here. This is faster just because we only have to do one calculation, and it's not really even a calculation because we know that all we have to do is set this term equal to 0, so we have our q value telling us where our function is going to be at the points where tan is usually 0, and then knowing the sign will tell us the shape, which way it's going to go up or if it's going to go down, and then this number here, this a number, is going to tell us the distance between each of our points. So usually with our tan graph, we have a distance of 1 unit between each of these points. And in this graph, we can see that we have 2 units between each of these points. And that's because we have a value of 2 over here. So that is how we can very quickly and easily sketch out these tan graphs without having to do very much work at all.